Okay, today we're talking about a chilled water pump manual control circuit. Okay, to give you some context, in this commercial office building, we installed a new chiller, new water pumps, and a new BAS, building automation system, and new VFDs, variable frequency drives. So you may wonder, why do you need a manual control circuit then, if you got a BAS? Well, we soon found out that the way the HVAC contractor programmed the BAS was incorrect, and it kept running the chilled water pump 24 hours a day, 7 days a week, even when there was no call for cooling in the building. We had lots of communication challenges and frustrations with the HVAC contractor. So the building owner just asked me to come up with a solution to reduce our energy consumption and not run those chilled water pumps 24/7. So I did a chilled water pump operational cost analysis that you see here. To run one chilled water pump 24 hours a day, 7 days a week, you can see the motor specs here: 460 volt, 3-phase, 12.5 amps, and these are 10 horsepower chilled water pumps. Okay, and operating that 24/7 here in Colorado with our rate structure, it's costing us between $680 and $900 a month. That's $8,000 to $11,000 a year just to run this one chilled water pump. That's a lot of money. And you can see the energy consumption, and of course the time of day, the time of year, the rates will fluctuate as well. So you can see by reducing the runtime to just 8 hours a day, let's say during regular business hours instead of 24/7, that's a 66% reduction, which will save us $453 to $620 a month. So that's several $1,000s a year that we're going to save by reducing that pump runtime. And that's also going to reduce the amount of wear and tear and hours on the equipment. And so our monthly energy usage or consumption would drop from 5,935 kWh down to 1,978 kWh. So ultimately, I narrowed down our options to two viable options where we didn't have to depend on the BAS programming. First option was this, and you can basically see in this wiring schematic, controlling the VFDs or the 460 volt supply to both VFDs with these contactors. And the coils on the contactors would be energized by a programmable digital timer, so we can set the time of day that we would allow 460 volts to be supplied to the VFDs. As a safety, we also have, or are going to install, a temp switch up on the roof at the chiller, so during the wintertime, if it gets really too cold, that temp switch can also activate the coils on those contactors to run the chilled water pumps to circulate water, especially through the plate heat exchanger. Ultimately, here's what we went with. Much simpler, no contactors, no messing with the 460 volt wiring. We stuck with the 24 volt low voltage wiring. And what we did, again, everything's still controlled by that programmable digital timer, still have the safety switch at the chiller, but now I simply installed a power supply, and it's 24 volt output DC, because the VFD input control terminals are 24 volt DC. And so basically the way this works is when the building automation system is calling for one of the pumps to turn on, that 24 volt signal from the BAS doesn't go directly to the VFD input terminals. It goes to our programmable digital timer. And if the programmable digital timer says, yes, it's the right time of day to allow the pumps to run, then that signal will go through to the VFDs, and the VFDs will turn on the water pump. The other thing we have here, and again, the reason why we have that power supply is in the event that we want to turn on the VFDs to run the water pumps, we need to be able to send a separate 24 volt signal to those same input terminals on the VFDs. And we're only going to do this on VFD number 2. And it's important that we're not sending two separate 24 volt signals to the VFD terminals at the same time. So that's where this relay is key. This relay up here, if you notice, it's a single pole double throw. So in its normally closed position, the BAS will send its signal to the VFD. When that relay is energized by the safety switch up on the chiller, the switch will change positions and the normally open terminal will be closed. And that's where the 24 volts from our power supply will then go to the VFD to turn the VFD on. So that way we're never allowing the 24 volts from the BAS and the 24 volts from our power supply to be simultaneously trying to energize the VFD. So I hope that makes sense. The step-down transformer, that's taking 120 volts, stepping it down to 24 volts to operate the temp switch up at the chiller. And the programmable digital timer operates on 120 volts. So just wanted to clarify that. And so here's a close-up view of the power supply. So you got 120 volts coming in on the bottom, 24 volts DC coming out the top. Here's the specs for it. And it attaches to just regular DIN rail. See right there how it attaches. And I bought this online, I believe on Amazon.com. It wasn't very much, I want to say 30 or 40 bucks. And then here's the relay and the specs for it. And again, it'll attach to DIN rail. So again, when that coil on the relay is energized, it's going to send the 24 volts from the power supply to the VFD to turn on the water pumps. Or it'll just allow, in its resting state, the 24 volt signal from the BAS to energize the VFDs and turn the water pumps on. But again, if the programmable digital timer says, okay, yeah, this is the time frame that we want the pump to be allowed to run. And you can see the contacts in there. You can see there's normally a closed and then a normally open. And this has a little LED that lights up when it's energized. And the terminals are all labeled as screw terminals. And I had to buy this black holder for the relay separate. It didn't come with the relay. And again, there's the specs on the side of the relay. So if you look in the back inside cover, not the back cover, the inside cover of the VFD, you can see what each of the terminals is labeled. And this is what it looks like before I installed our wiring. So mainly the wire that tells the VFD to turn on the pumps in a forward direction is that red wire and white wire. That's what we need to tee into, if you will. And here you can see after how I've teed into that. So it goes to our programmable digital timer switches, then back into the VFD, and that's what that black wire is, coming from that programmable digital timer. And of course I had to land another 24 volt negative wire on the common terminal there that you see next to the white wire. So I simply mounted this enclosure that we already had as a spare stock in our facility, mounted to the wall. So you've got 120 volts coming in the left-hand side, and you can see our 24 volt wires go out the top into our programmable digital timer. See our step-down transformer. There's our power supply, our IDEC relay. And then here's that programmable digital timer. You can see the 24 volt wires or shielded wires going out the left-hand side there to the VFDs. And then there's one going out the top there that's going up to the roof to the chiller temperature switch and provides power to the temperature switch. So pretty simple. I installed the temp switch to this bracket up at the chiller. Underneath the condenser coils there, you can see there is a rail I mounted it to, and our 24 volt wire comes in. Here's a wiring schematic for that temperature switch. You gotta connect terminal 9 and 10 on this one to send power out back down to energize that relay. As it looks like all finished up. You can see the temp probe comes down to the outlet pipe of the plate heat exchanger. I just sanded off some of the paint there. And I'm going to use this thermal glue to attach it. and help improve thermal conductivity for accurate temp reading. That's what it looks like. Then I'll reattach the insulation, seal it up, power it up. You can see it's working, giving us an accurate temp reading. And then for this particular temperature switch, here's the different set points and parameters that you can adjust. And you can see the VFDs are powered on, chilled water pumps are operating normally. So this setup is working great. I hope this video helps you and serves as a cautionary tale. Be very careful who you hire to do your HVAC work. Make sure you have everything in writing and that everything is clearly spelled out before you sign any documents. And now I'd like to tell you about our Practical Facilities Maintenance Handbook, available now in ebook and paperback format. It has common facilities documents, signage, tags, resource and training material, as well as common shop equipment drawings that you can use to fabricate shop equipment for your facility. The link for this book is in the video description below. Or if you need mugs, hats, shirts, or weather-resistant stickers for your facility, there is a link for this online facilities maintenance store where you can procure the products that you see here. I hope you find this helpful. Please like, share, subscribe, leave me a comment, and thanks for watching.